Hi class, my name is Victoria Cazares and I'll be covering the compound saccharin. Saccharin, the molecular formula is C7H5NO3S. The molecular weight is 183.81 grams per mole. The flavoring agent and non-nutritive sweetener. Physical description is its odorless white crystals or crystalline powder. Aqueous solution is neutral or alkaline in litmus, but not alkaline to phenolphthalein. Effervesces in dry air and is intensely sweet to taste. The history of saccharin. In 1879, the discovery of saccharin. Saccharin was discovered by researchers at Johns Hopkins University. Even then, it was a boon to food manufacturers and consumers, especially those with diabetes, who could use the new ingredient to sweeten their foods and beverages without calories or glucose reaction associated with many sweeteners. Saccharin, it was widely considered to be the most researched food item, developed in 1879 by chemist Konstantin Thalberg as the first artificial sweetener. Saccharin has been a popular choice among consumers looking to cut calories. This is because the odorless white crystalline powder, sometimes known as sodium saccharin or calcium saccharin, is a non-nutritive sweetener, meaning that it does not have any nutritional value for humans and contains 0 calories. In 1957, the first packet of Sweet and Low is manufactured by Cumberland Packing Corporation in Brooklyn, New York. In 1972, rats fed very high doses of sodium saccharin in a lab developed bladder tumors and sparked concern about the saccharin safety. When a popular study questioned its safety, the FDA reported concerns about saccharin's risks to humans and began to work on a proposed ban. This led to the establishment of the Saccharin Study and Labeling Act of 1977, which was intended to inform consumers that saccharin-containing products were potentially carcinogenic. In May of 2000, the U.S. National Toxicology Program releases the 9th edition of its report on the carcinogens and announces that saccharin has been removed from the list. In December of 2000, President Clinton signs federal legislation that removes the saccharin advisory label on foods and beverages. In April of 2010, the EPA announces support for the amendment to remove saccharin from the list of hazardous substances. Saccharin is a no-calorie artificial sweetener, 700 times sweeter than sucrose, also known as table sugar. It has remained a popular choice among manufacturers marketing these low-calorie, sugar-free diet foods. Saccharin is used in soft drinks. Saccharin is also used in baked items, foods, and candies. Used in medicine. Saccharin is also available in toothpaste and also a salt. Saccharin is safe for consumption. Consensus from several top health institutes, including the World Health Organization and the Joint Expert Committee on Food Additives, reveals saccharin is safe to consume as a food additive for average individuals. Given saccharin's use as a food additive, the most common method of exposure people have to the sweetener is via ingestion. Human studies on risk associated with consumption began in the earliest in the late 1970s with analysis like that conducted by Kessler and Clark. After public outcry, especially from diabetics who relied on the artificial sweetener, the FDA urged scientists to further study the sweetener's safety. Intriguingly, many of the earlier studies were not replicable or provided conflicting evidence, leading the FDA to reinstate saccharin's decree of safety and eventually repeal the 1977 Act in 2000. Since this time, saccharin has remained on the list of substances that are safe to consume, despite opposition by some fringe groups who continue to report misleading information about the sweetener. Due to controversy surrounding saccharin's safety in the 1970s, Dozens of research and analysts and reviews have covered the artificial sweeteners' risks towards humans and animals. Though consensus regarding saccharin safety has reached by 2000, many consumers are still wary of the risk factor of the substance, and controversy remains. According to the University of Minnesota, 14 studies completed on lab animals before 2005 failed to provide evidence of saccharin as a carcinogenic substance despite exceedingly high exposure rates. Furthermore, saccharin can cause allergic reactions when exposed to skin, particularly for those with a sensitivity towards this and similar chemicals. These susceptible individuals are likely to experience future skin irritations once an allergy develops, but establishment of allergy typically requires exposure to incredibly large doses. Saccharin risk. Beyond consumption, however, saccharin does pose a threat, especially to those who are exposed in industrial settings. When inhaled, saccharin is toxic, particularly over levels of 10 milligrams. The risk of exposure to toxicity with this chemical becomes especially disconcerting when fire is introduced, as this reaction results in the production of nitrogen and sulfur oxides, which are poisonous to humans. Industrial workers who create, process, and blend saccharins are encouraged and oftentimes required to wear special protective equipment to avoid unsafe exposure to these substances. Saccharin's risk to animals. Though the evidence about saccharin's safety for humans is quite clear, studies on animals have proved more conflicting. During the time of heightened concern about saccharin in the 1970s, researchers were not only evaluating safety on humans, but also completed several tests on lab animals, specifically rats. Initial studies demonstrated male rats exposed to saccharin were significantly more likely to develop urethral bladder tumors. The authors recruited 1,038 participants, half of which were generally healthy, while the remainder were diagnosed with various stages of bladder cancer. All participants were given an equal amount of saccharin to consume, but even after controlling for the other variables such as smoking status, age, and occupation, the results showed no increased risk for bladder cancer among people who already had the illness or people who were healthy. This study, however, involved ingestion of saccharin cyclamate compound rather than pure saccharin. Unlike saccharin, cyclamate remains unapproved by the FDA for use as a food additive, though it should be noted that concerns about cyclamate are not cancer-related. Nevertheless, information from a study using a compound is not sufficient to determine any carcinogenic properties of saccharin alone. Despite myriad studies demonstrating saccharin's safety in humans, there is continued concern about its supposed link with cancer. However, several important points should be considered. First, saccharin lacks two main characteristics typical of carcinogens. It passes through the body without being metabolized and does not influence the structure of DNA. Second, links between saccharin and cancer have never been found in human studies, but have only presented in animal studies of lab rats. Conclusion. Despite continued controversy, saccharin appears to be widely regarded as safe for consumption among the scientific community. Decades of research illustrate no viable connection between saccharin and deleterious health outcomes in humans in terms of immediate risk of toxicity or exposure to agents which may cause cancer. For this reason, the FDA has approved calcium saccharin for use in commercially available foods, beverages, medicines, and dental products, and there appears to be no indication saccharin will be removed from this list as it poses no threat to humans when ingested as intended.